Hello, hey guys. I don't know if anyone's actually watching quite yet. If you are, you're extremely quick, so congratulations. Yeah, okay, so we're live on X. Let's just wait and see if we can get some people joining the stream. Cool. Yeah, so how's everybody doing? Remy, how are you doing today?
Yeah, super excited to kick this off. And I think we can probably just get started. And this is going to be recorded anyway. So for people joining late into the stream, feel free to just, watch from the beginning. So yeah, super excited to kick off this summer game jam. So I'm Remy, I'm the founder of Inco. And let me share the screen, slides. So excited to kick off this summer game jam. And we'd like to say that this is co-hosted by Inco and Megapod, and then we really appreciate the participation from some other partners such as Imagine AI, Base, Sun Arcade, Kamagochi, and also others that will be announced very soon. So in terms of price tracks, we have two main tracks, and the goal for this 2-week competition is really to build the best games on Base. I'll chat a little bit more about our price track first, and then GC from Megapod is going to introduce their price track. So for Inco, what we're looking for are basically new game projects that utilize Inco Lightning, which is our smart contract library. And we have 3 prizes. So the first prize is $3,000, second prize is $1,500, and third prize $500. Here's what we're looking for. So there are core things that we care about. So one is, are you creating and utilizing new hidden mechanics using our library? So that's like 25% of the criteria. The second one is around the completeness. Is the game actually playable from a third-party perspective? Another 25% is on the creativity. So we're always delighted if you can come up with something completely novel that hasn't existed yet in Web3. And the last one is obviously this is a game jam, so fun is going to be the last component of it. And so all the prices are going to be paid out in USDC, and we essentially have a top 3 prices for our track. And I'll pass it on to GC from Megapod.
GM. Yeah. Hello, everyone. Thanks for having me on. I'm just going to talk about the Megapod price track briefly. We have $5,000 in total. Half of that is going to be split in cash. Half of that is going to be in lottery tickets. So someone may win the jackpot, or win a lot of money with the prizes. But essentially, what we are looking for is builders and devs kind of building on top of Megaport and using Megaport as a core mechanic in whatever they choose to build. One thing that we're really looking for is something that's unique, something that's a bit out there. Doesn't necessarily have to be a game or anything gamified. We're actually seeing quite a lot of projects integrate Megaport in a way that is being used for user acquisition, user retention. Like teams are using Megaport tickets to reward players, get players in, or get users in. So yeah, there's quite a lot of different experiments that we're hoping that would come out of this. We've got a lot of different ideas in terms of how this could be developed, and yeah, that's pretty much it. All the project is on chain, so you can interact directly with the protocol. And yeah, we're just looking for fun, creative ideas on top of Megapod.
Yeah, thank you, JC. Yeah, super exciting new primitive that's fully on chain, and I'll be very excited to see what people are going to build using Megapod as well. So next, on to the next slides. So timeline. So the workshops are starting today. The official hackathon starts next week on the 3rd and ends on August 14th. Obviously, you are welcome to start brainstorming, forming teams between now and August 3rd. And the deadline here is actually 6 p.m. EDT. So this is East Coast US time zone. So make sure that you submit on time. And there will be a couple workshops. So today, tomorrow, and Friday. So this is the kickoff call with us. Tomorrow, Megapods will be introducing their stack and then their lottery dynamics. Friday, we have 3 workshops from Imagine AI, Sun Arcade, and Kamagochi. We also have other workshops next week that we will be announcing pretty shortly. And if you are not on the Luma list yet, so here's the QR code. So if you register, you'll be able to receive counter invites to all these workshops. And one more thing to mention, that these workshops will always be live streamed on X and also YouTube Live. So in case you miss any of them, no worries. You can always go back and watch them. So there is a Telegram group here. So here's the QR code. You can also just type in this directly. This is the Telegram group to get any technical support, but also if you want feedback for your use case. So Inco and Megapod have their own dedicated channels within this Telegram group for you to reach out to. A couple of rules. So the first one is please build this during the jam to make it fair. And obviously, if you are bringing in an existing project, feel free to, actually, you should definitely disclose this. We also welcome that. It's just that's something to make it fair. Like it's helpful for us as judges to understand, if this was from scratch or, something that you continued from a prior project. Second, again, the deadline is August 14th at 6 p.m. EST, and late submissions won't be accepted. So please make sure that you submit before that. Third is you definitely want to integrate either Inco or Megapods into your core game's logic, core loop. And this is something that, if you're interested in basically winning the prizes from the 2 tracks, then this is the minimum criteria. 4, you want to ship something playable, ideally, so something that people can play around, test out. And so we actually recommend you to maybe host this somewhere that people can easily access and then just click around, play around. 5th, we would like you to also submit a demo video, just a short walkthrough about how the game works and then how it uses Inco and Megapods, just to help us quickly understand what your project is about. And then we would like you to also share your repo with the detailed write-up of whether or not your project is proprietary. And then obviously if it's proprietary, that definitely let us know on the side, and then we would evaluate this separately. We welcome team up to 5 people, but we also welcome solo builders. In fact, I do think there is a trend here to have more and more solo builders, and today using AI, it just makes this a lot more feasible, even as solo builders, to basically win prizes. 8, this is again, pick your track, Inco or Megapod. Prizes on the prize details on the resource pages, and you're also welcome to use both. In fact, actually, that would definitely add in more creativity if you're able to somehow utilize both Inco and Megapod for your projects. 9, play nice, be respectful. Harassment won't be tolerated. And lastly, 10, when you submit your project, you agree to our terms, which are on the website. So everything I just mentioned so far, you can find this on this blog page. So here's the QR code. So everything about the hackathon rules, the prizes, workshop schedules, and all the details to get started. So next, I'll be going over Inco very quickly to explain basically our stack and then what you can build with our stack. So you might wonder, Inco is the full stack privacy solution for private blockchains. What does it have to do with gaming, right? I'll definitely cover that towards the end. But first of all, if you're a builder in the space, you've probably already realized that everything is transparent in crypto, right? Whether you use Ethereum, Solana, Base, that's the reality of blockchains today. They are just completely transparent state machines. Now, there are a few privacy projects that already exist today, and then here are a few reasons why we think they fall short. First, it's really a co-star problem. A lot of these chains are completely separate L1, L2s, where you do have to migrate to a new chain just to get the privacy. And so what this means for you as a developer is that, you kind of sort of have to rely on them to also to have the liquidity that you want, the ecosystem, the user base, right? Second, we do think the user and developer experience today for privacy has always been lacking historically, but things are changing now. But the places that we thought were lacking, one was around programmability. So historically, privacy tools lacked sort of the flexibility for you to customize any specific logic that you wanted, or lack composability. And then the DevX has always been quite challenging because you either had to learn new languages, new programming languages, or learn new tools, which sometimes do require some steeper learning curve. The second is the UX oftentimes is also incompatible with existing wallets or DeFi applications. So you just end up having to have a lot of friction for your end users. And lastly, this is about compliance, but also could be around decryption rules for games. So far, I would say a lot of the pricing projects have been pretty rigid on these things. We offer a pretty easy way for you to change any access control rules, delegate viewing, etc. So I'll cover this a little bit more later on. So you can really think of Inco as a private compute layer that sits on top of existing blockchain. So we use a encryption-based approach, and so this is where we get to expand the capabilities of existing blockchains. And so the core product or protocol that we're offering here is a confidential smart contract library. So what it does is it enables builders to build private applications that are fully composable on chain using familiar language and tooling such as Solidity. You can use things like Hardhat, Foundry, and you can also use all the existing wallets. And so the way this looks within the EVM is that we have new data types. So normally you have things like regular integers, booleans, bytes, addresses. What we offer here is an encrypted version of that, which is EUINs, eBool, eBytes, eAddress. And these are not only just encrypted states, you also get to compute on top of it. So what does that mean? So if you were to have, like, let's say 2 encrypted integers and you wanted to add them together, this is where you can add you can use something like e.add to basically tally them up. You can also subtract, multiply, also do comparisons. So this is where you can really expand your game logic beyond just the public layer. If you have any hidden game logic, let's say you wanted to compute the result of a battle without leaking, let's say, the stats of the players, you could basically add, divide, multiply all these different stats, and then at the end just reveal, right? The other benefits, so this is so one, it is the simplicity of writing code. So these data types and operations read and write like regular Solidity. You get to tap into existing user base. So this is actually deploying on base. So you get to tap into all their TVL or also all their existing user base where these things already exist. This is essentially just a Solidity library. So you can just import this and then directly access these data types. What we think we do best here is essentially we offer a very ergonomic and simple way for developers to build applications. And so this is because of the familiar Solidity language, familiar tooling. And so overall, if you are already a Solidity developer, it should take you less than 20 minutes to get started, as opposed to learning new languages or new dev tooling or wallets. One thing I wanted to introduce is really around this idea of composability, which if you are a DeFi builder, you're already super familiar with this concept. Essentially, everything crypto can be thought of as composable Legos. So at the core, you have something like ERC20 that can be used as a primitive to do things like lending, swapping with Uniswap. You can also hold ERC20 when the nodes is safe, or you can do things like flash loan. And the reason why this is powerful is basically composability creates network effects. And it's really one of the interesting property that Web3 has, where different applications get to build on top of each other and then together create something even bigger. With the confidential library that we offer, we also have this ability to enable composability. So this is what we call private shared states. Because all the states are fully on chain and private, and you get to compute on top of them, can now basically build different contracts and primitives that can talk to each other. So just as an example here, you have a confidential token that can be utilized to, let's say, for a confidential voting use case. So you could extend the private amount on the confidential token to cast a private vote, right? So that's just one example. You can also do something like payments, lending. In terms of gaming, what this could mean is maybe you could start thinking about some ways to mod certain games, right? So you could build a core game logic with hidden information, and then people could build other modding primitives that are going to be fully composable on top of your hidden game logic. And just to reiterate, what this really means is that you can expand the use cases by having other people to build on top of your primitives, right? So for example, on top of the confidential token, you could build private betting, right? Just as an example, you can also enable private trading and so forth. So the way we enable decryption is super flexible. Everything goes on chain. So all the logic that you want to program can be fully specified and changed fully on chain via a, let's say, transaction, governance, or even specific conditions, right? The key thing here is that basically you get to program however you want this to be. So let's say at the end of a poker card game turn, you want all the players to be able to see, everyone's hands. You can program that logic fully on chain. Or for example, at the end of a season or at the end of a voting period, you want everything to be decryptable or only decryptable by a certain party. Then you can also program this on chain. For something like a mafia game, for example, where you get to investigate, right? So there's this role called detective where you get to investigate different players and get to see their identity behind. You can also program this on chain. So this is super flexible. You really get to try, play around the stack and then come up with different decryption rules, however you want it. And again, you don't need any new wallets. Just use your existing stack. It will work. So just quickly on the architecture, how does Inco work? So we propose a alternative privacy construction as opposed to a commitment-based system, which you can think of ZK. So encryption-based systems are, things like TEs, FHE, MPC. Here we're utilizing TEs, and there are a couple components here that we put together to make this entire stack to work in a very seamless and verifiable way end to end. And so just from a high level, Inco is a private rollup, and it's actually a base private rollup. So I'll explain a little bit more what I mean by this. But at the core, basically, you have a TE that has a shared secret. And then within the TE, we run the Helios Light client. So every single compute and decryption rules are going to be verifiable end to end. So anything that happens on chain gets reflected in our privacy layer very seamlessly. And there's no way for us to cheat or change the rules because we run a light client within the enclave. And so how is this a base private rollup? It's based, meaning that it's not because this is deployment based. It's based because all the ordering, sequencing, and DA happens on the host chain. So normally this happens on Ethereum, but because this stack is currently deployed on base L2, you can think of Inco kind of like a base private rollup as an L3, but on top of the L2. So what happens is user casts transactions directly into the host chain, which in this case is base, and the events gets emitted, and then we then mirror process basically this entire process end to end, and then there is incremental settlement back into the host chain, and then if let's say the rollup loses its states because the DA layer is on the host chain, we get to replay every single private state from Genesis without losing anything. And so the question is like, so what does privacy have to do with gaming, right? So what's new in on-chain gaming? We strongly believe that this is a new design space because the old paradigm is that everything on-chain is transparent by default at all times. And so this wouldn't make sense for you to build a lot of use cases, including things like poker, where it's a bluffing game, right? So how can you bluff if I can already see your cards on-chain? This doesn't make sense. So if you think about like all the games that you grew up playing, whether it's Pokemon or Yu-Gi-Oh, there's always some kind of hidden elements, right? This is what makes the game a lot more fun, challenging, uncertain, and competitive. And so this is where we believe that, by introducing encrypted states on chain, encrypted secrets, we essentially allow people to build completely novel games with a different experience that people have not experienced so far in crypto, because everything was transparent, right? So think of like the hidden strategy games. So a simple illustration here is Battleship. I need to basically guess your hidden positions for me to attack it, right? Or something like a Secret Alliance, something like a Mafia game where the killer needs to be hidden, because the goal of the game is for the people who are not killers to find out who the killers are, right, and vote them out. Or there could be a lot of guessing games like gacha games, dice games. So this is where we really believe that on-chain gaming can have a second wave where people build basically new interesting primitives and games that couldn't exist before. And the other thing that we introduce here is randomness. But this is not your typical, VRF. This is actually hidden randomness, meaning that if you wanted to generate cards that are hidden by default, we can allow for that, right? If you want to generate basically um, different properties for the players, but also want these stats to be hidden, we can also enable this. And the cool thing is that this is going to be fully on chain, and it's also provably fair based on our architecture. So we have a couple demo use cases that you can play around, click around. One is a mines game. So this is based on the classic mine sweep. Basically, you click on tiles, and then some tiles could have bombs, but you get queued whether or not they're bombs, within the vicinity. This is a simple hangman game. There's a hidden word. You're supposed to guess what the word is before your amount of tries runs out. And then there's a few basically mini games that here that you can try: coin flip, slots, plinko, dice, where they are basically, this is utilizing essentially the hidden randomness feature. And to make this process a lot easier on the developer side, we put together this confidential deck. So essentially, it's a very easy to use library SDK. So if you want to build a card game, we've already packaged a lot of the features into simple to use primitives. So for example, if you want to shuffle cards, you can use this directly. And so think of a game, let's say, Uno, right? You can have 60 something cards, or something like a Yu-Gi-Oh. You can specify basically the range 1 to, let's say, 62. And then you want this to be shuffled and return you a list of hidden integers, right? So now you have a shuffled deck, essentially, fully on chain. And then with the draw feature, you get to draw basically from this deck, and then automatically allow the player who draws basically the deck to be able to view the card. You can also deal card privately to specific players. You can reveal the cards publicly, or just off chain. And then settling this is basically revealing the cards to everyone. So definitely check this out if you're planning to play to build any novel card games like fully onto Yu-Gi-Oh, Magic, Uno, poker. This is going to be extremely easy for you to use. And on top of this, we also have an AI skill on the Inco docs, and highly recommend you trying this out. Personally, I've been able to one-shot a lot of the games using the AI skill, and it's also a lot of fun. Yeah, you can also see some examples here that is utilizing this library. A couple examples here, including Blackjack, Raffle, Mafia, the simple war game. Again, this is the link. Feel free to try it out. And then next, I'll pass it along to Sudeep, who's our DevRel at the Inco team, who's going to give a more technical workshop. So he's going to walk through a couple of game examples, the contracts, the different templates, dependencies, and also the docs.
Thank you, Remy. So yeah, I'll start off by going over the basic concepts and then introduce the games that we have. And we will be walking through with an IDE as well as a front end where we'll be making a game using the confidential deck template that Remy just mentioned. So let me just quickly share my screen here. Um, yeah, Great. Are we live? So the basic concepts we've already introduced. That is like, hey, you can do encrypted addition, subtraction, multiplication, and divisions. And there are a lot more operations that you can work on. And an important concept of encrypted values on chain are access control. How do you selectively reveal the information or the computation that you've done, the results of them to specific users? So this is where access control comes into play. You can allow a specific user to view a value, an encrypted value. In this case, in this example, it is the encrypted balance. And the the use case that we are gonna explore today is very familiar to e-lists because a card of deck will include a number of values. So when you're working with blackjack or any other games, it's a set of 52 cards. So we have optimized our library to allow you to compute on top of multiple values, where the general approach would be very expensive. So you will have an encrypted list or an encrypted array of values on top of which you can do operations. Um, so we have built the game SDK where you're able to create a deck of cards, shuffle them, deal them, and also draw and settle them. So all of them are bundled into a confidential deck template where will also be explaining exploring some games. So we have few games here already. So you will be able to get an understanding of how these work on confidential deck. Okay, I'll be showing this link later. So war is basically like, hey, um, whoever deals gets the highest card wins. So in this case, ace has precedence, then comes a king, queen, and the following numbers, right? So this is a two-player game. So how this works is, I'll give a small walkthrough. Both the cards that are dealt are using something called E-rand. So whenever you draw a card, it creates an A list of 52 cards, shuffles them, and deals the first index to you. So we'll be walking over the code soon, but you should able to work with like shuffled cards, encrypted dealing, as well as you'll be able to reveal them in one go and claim your funds. So that is what we'll be building today. We currently have like 4 games, that is War, Blackjack, Raffle, and Mafia. However, for today's setup, I will have instead of having a two-wallet game, we'll be creating a version of War where you'll be playing against the computer or the house. So before getting started, let's set up a few things. As Remy mentioned, we do have skills as well as MCP servers. So how that would look is, once you install them, you'll be able to check all the MCP servers that we have. And Inco MCP allows you to browse the documents as well as work with the repositories that we have made public for the game itself. And we also have the skills that is installed. So you can just go to Cloud Skills and you can start with slash lightning. So slash lightning and that, okay, if you can just install it. Just give me a you should be able to install the skills from this repository. Either of these will work. Just copy this and you should be able to add them. Getting back to the library itself. So there's a section called Inco for Games under docs, which will allow you to work with the confidential deck kit. We can start with the examples as well itself. How do we run it? So there's a repository that we have made public, which contains the contract. So I will be walking you through what the contract does, the logic in it, so that you can modify it however you want and use it in your games. And then we'll start building war for a single player. Yes. So a few things. Keep your We are live on base Sepolia as well as base mainnet. Ensure you have your RPCs, your private keys and everything ready. So you can basically fill this example up. I have an env of my own, which I will be using. Great. So I will be walking through the contract while we generate the code itself. So a few things to mention here. We are currently working with the standard card size. You can also change the deck size based on the game you want. So what you should be looking at is the kit itself, the confidential deck, which is where you can make changes to the logic that we have over here. Basically, the deck size, be it the shuffle mechanism, the draw mechanism, or any fees that you want to introduce to this, you will be making changes here. So how do we start? Firstly, we check our MCP servers. We see that MCP server is live. And what do I want to build? Hey, I want to build. Initially, we would have to give some context about Inco, and that is done by the MCP server. So you would want to say, tell class, want to build an on-chain war game using Inco encrypted types for a card game. So you shouldn't build a random war game using encrypted types. You, so the best way to approach this, you can ask it to refer the MCP, Inco MCP. That's when it will basically prompt you to refer it. MCP, and you might also want to reference your confidential deck template to understand how we can deal, draw, and shuffle cards for the game. This will be against a computer. So remember when I told you we can shuffle values. We also have a function called eRank. So it generates a random value whenever you call that fully on chains, and it just returns you a handle, encrypted handle. But the value is hidden until you reveal it. So use encrypted randomness. So we also have frontend for this. So whatever assets that you see on the game that on the browser that I just presented, the code for it is fully open source. So you can use Inco assets, or you can use some of the contract interaction logic. So we have two things. That is the Solidity SDK itself, where you'll be able to work with the smart contracts. So if you want to do operations on the smart contracts, this is the library you'll be using. And since we are using encrypted types, we have some helper functions which allow you to call Enco's TEE, decrypt it, and show it to your client. So that is where the JavaScript SDK comes into play. So you'll be able to encrypt values and send as inputs, decrypt values that have been generated on chain, and attested reveal is a concept that we will be needing when we want to settle. So what attested reveal does is we basically query the co-validator asking, hey, is this the correct decrypted value? And the signs attesting that the value that the user is trying to claim as the value of a ciphertext is actually correct. So this way, whenever you reveal a card, this attestation basically signifies that yes, the value is not malformed or been manipulated by the user. So that is about attested reveal. So the JS SDK is fully bundled into the front end repository over here. And I will be going over the installation, but there are two main things that you should be installing. That is the Lightning JS SDK, as well as the Lightning dependency for the smart contracts. I will be showing where we'll be importing both of these libraries when we start getting into the smart contracts. So let's finish the prompt. So you can either choose to test it using scripts or test files, or you can also choose to test it over front end. So we're gonna just directly test it over front end as we are working with base Sepolia. I will also walk you through how you can test it on a local ML chain, so that we'll be like, so it is faster, it's significantly faster and costs much lesser to work with, and tested on this Sepolia. So ensure your ENVs are filled, um, and you don't have to tag Claude saying like your ENV is there, but deploy and configure the front end. So be as descriptive as possible about your game. So what do you want to do before, like, hey, starting off a game is, it's easier for me because the war card game, we have a template of it already, so it can refer to it. However, if you're working with games that are not here, that are novel, you would want to explain the game mechanics in full depth before you start off with it. So while this is working, I would like to walk you through the confidential deck itself. So the Lightning library that you will be installing, right? It's right here. Okay. So yeah, this has to install dependencies, and the error will go. So elist is the type that I said, like, hey, you can create an array of elements of values, and you can do certain operations over it. That is, you can either like arrange it, or you can shuffle it and draw a value from it from a specific index, or you can also like arrange it in a specific order, ascending or descending. So as you can see, it is we're trying to search our MCP. So we allow all MCP search. And so this will allow your AI to get sufficient context about how Inco works and how it can start working on the encrypted types, and it will be able to install all the dependencies and everything. Now, coming to the contract of confidential deck itself, you will see when you call new shuffle deck, it basically calls the elist function called shuffle with the range that you want. So from 1 to whatever size that you are giving here. So, and make sure that you allow the elist itself to this, to that contract which is calling this. So this way, you won't be losing the values of this. So the contract has access to these values, so that on the later stage, you will be able to do operations on top of it, and then reveal it to whichever party needs to see it. For example, when you deal deal to a specific user, right? It will draw a value. So if we go to draw, it picks a card from the deck. And the drawn is basically like which is the latest drawn value. So in an array, if it has drawn index 0, it will just check, hey, which index has been drawn. Let's draw a card from next index and increment the index. So that is what this function does. So that no one person gets the same card because it's a multiplayer setup. So that is basically how draw works. And we allow it to the user that is getting the card. So if I am playing against a user, another user, he'll be able to only see his card. I can only see my card. So that is the allowance. So if you have like a multiplayer setup where there's like partial visibility of certain things to a different user, you can also add like, hey, this element dot allow another user. So this way, you can modify the like level of confidentiality. Perfect. And reveal card is basically when you reveal the value of a specific card to the blockchain. So till now, you were using the JS SDK to see it on the client side, the value on the client side. But reveal cards basically sends a transaction which allows everybody on blockchain to view the card value. So that is e.reveal. Now this is used when you want to settle a game, or you want to like finish the game, and it no longer matters whether the card is hidden or not, or if when a card is dealt, that needs to be seen by all the players on the uh, session. And yeah, so verify value is where I was talking about attested decrypt, right? a tested reveal. So um, what it basically does is it gets a signature from the co-validator and provides it to the smart contracts and checks, hey, if this value corresponding to this handle is correct or not. So that is where we use verify value, and this is used in multiple places. I'll be showing where. So we use verify value in the card lab when we want to um, basically, just a second. I'll show it in the contracts itself. Yes. So when you want to check whether, so when you're settling it, right? When you're settling around, we reveal both the card of the house, we reveal the card. Oh, just a second. Okay. Yes. So this is trying to run against the local host. We will be running it against. Yeah, perfect. So what verify value does is, I've explained what verify value does is. So in our smart contract, when we want to reveal the player value as well as the house value, we verify whether both the values are correct, and only then we reveal the outcome. And the logic for this is also written over here in the card library. You can either use this or modify based on your requirements. And yeah, so the precedence is the rank ace takes the highest value of 11. So if you go here, yeah, in this case, ace is of the highest precedence and 6 is lower. So you'd definitely the house wins. And in case of let's say blackjack, right? Just give it a sec. Aha. So in blackjack, when you have to, there was a game that was going. Just I'll be claiming this. Yes. So as you can see here, you either hit 21 or beat the dealer. So it's 8 plus 11 plus 2. So that hits 21 value, the value of 21, and we win. So give it some time to decrypt the dealer values. Um, Decryption happens on the client side, so you might have to sign a message saying for your values, but for the computer's values, you'll be able to see it soon. So this and you'll be able to claim the uh, funds that you put. In this case, we are using ETH. You can also use confidential tokens if you want to make sure, like, hey, the winnings are also hidden. So it's up to you. Now coming back to the deck itself. Perfect. Yes. So this logic basically gives the precedence and the the suit of the cards. So then we have the games that I was talking about. So let's go over War first, where it's a multiplayer setup. Before I show you how a single player setup works, because this makes more sense for the games that you'll be building, since people will be playing against each other. So you create a room and multiple. Right now it's sequential. You can't choose who is like basically joining which room. You can also do that, or you can just follow this like format. So match room just checks if there are any open rooms, and it joins that. And so when you click deal, right, so it calls deal 2 from the card library, which is basically a, a draw from the shuffle deck. So as you can see, it will get the index of this from the shuffle deck we have sent it in, and provides it to the first player and the second player. And as you can see in deal 2, it is allowed to the person that you are giving the cards. So if you go here, I can only see the card that has been dealt to player 0, and the person who has joined the room can only see his own card. Now, finally, once both the users have been dealt the cards, they'll be revealing each other's card. So we know the rules, right? Like based on the highest value, the winner is decided. So you would have provided some ETH, which is basically the fee over here. Check if the fee has been paid, and if the pot is greater than the fee that the user has paid. So, and then once it's revealed, you will be able to settle. So when both the cards are revealed, we settle with the value as well as the signature of the co-validator. So you will be able to verify, and then the funds are basically given to the user. So rank off. So this basically decides what is the rank of the card that the user was dealt, and if based on the winner, he gets the pot price. And you can potentially merge, settle, and claim, so the user can get his payout immediately. So there are some view functions that you'll need in the front end. Just check like, hey, which room I've joined, the number of rooms, and the handle of the card that I've been dealt. So you can go over these later on. So let's check what we have for base Sepolia. Uh, so yeah, in case of if it's against the house, right? It's basically like we are um in deal. Uh, yes. In this case, we will reveal the house card and the player card instead of the uh what do you call it? The second player. I'm just trying to find where. So we directly draw in this case, we directly draw to the user, and we'll be able to. I see that this has created a multi-round match. We might have to walk through this. All right. It creates a new shuffle deck, and each user is dealt, and the match has started. And you can open or close the round, double down after picking your card once per round. Aha, so this is slightly different from the one we have. Nonetheless, so I will be giving a walkthrough of how the front end would look once we're able to run the tests. Uh, Meanwhile, I'll be able showing one of the demonstrations I was able to wipe code before this. So this is also currently on local hosts. So this is the war solo that we had. We can open a new hand with whatever values you want. In this case, I'll just use 0.01, and you enter the game. So you'll be able to peek your card. So what peek your card does is, when I click on it, it will open a signature request. So what this is the handle that you're trying to decrypt, which is basically uh, that it belongs only to you, and it's on the client. It will decrypt on the client side. So when you confirm, you'll be able to see your value. So give it some time, because there's a small delay between the transaction going on chain and you being able to decrypt the value. Yeah, you see, I've got the highest value, so the chances of me winning are higher. So in our newest version that is currently being built, you can basically raise. You can say like, hey, I would like to raise the value, and then showdown, because given I already have the highest card, the chances of me winning are higher. So in this is just one round, so you will be able to showdown so that you can reveal what the house's value was too. And so when you click settle, that is when the value that you have gotten as well as the house's value will be revealed to the blockchain or globally. So you can merge most of these components to one component without having to basically uh, have so many clicks happening in the transaction, like in the front end. You can make the UX much simpler. Yeah, as you can see, I have one and I will be able to claim 0.02 ETH. Perfect. Let's go back and see how our test is working. Uh, Again, as you saw, since I haven't given sufficient context, the example that we have and the example that created is significantly different. Nonetheless, make sure you give sufficient context, and we should be able to play. All right. Okay. Given we're working with base Sepolia, this will take significantly more time. So what I can do is I will be sharing this repository with the latest front end. So it will be updated in the same confidential deck template, and we will be able to uh, work with it. So let me go over the front end itself. So you should be able to see the front end components over here and work with it. So yeah, we have most of the assets for the cards and a few other things in the public values. However, if you have more assets to work with and basically like whatever game assets that you have and the game mechanisms that you have, you should be able to work with it. And the JS SDK that we have over here is already baked into the front end that we have provided. You should be able to use attested decrypt, attested compute. So attested compute is a slightly more complex value. So this allows you to check whether like a value is more, you can compare, basically you can compare on a certain encrypted value without revealing it. So I want to check whether like, hey, is the card that has been dealt like greater than 10, is it an ace or not? So you should be able to do it using tested compute. Although use this very carefully because sometimes this can also leak information. And yep, all of these are baked into the front end. You should be able to work with it. So let's deploy it to base Sepolia. Oh, deployments take time on base Sepolia. And yeah, here's a smart contract address. So you need to fund in the in a multiplayer setup. The players play against each other, so you don't have to fund the contract. But if you're playing a single player setup, you will have to fund the smart contract. So, and also ensure like when a player joins, there's sufficient funds for them to play. Because if the pot size is not big enough, they'll not be able to join the game. So the ABA of the game is updated here. This is when so the smart contract itself is ready. Let's go over the tests. Oh, I wonder where it wrote the tests. Ah, it's over here. So you can basically go over testing against the local node over here. as opposed to working with base Sepolia. You need to make sure you have Docker installed. I do have Docker installed, but I'll be running it sometime. I wouldn't be running it right now. And so make sure you test it against hard hat first, and then deploy it to basically all of this. And once we are done wiring the front end, we'll be basically hosting it. So give it some time to do type checks and compilation. You should be able to play. There's one more thing that you might have to address. We have a polling frequency of 4 times every 3 seconds. So this is basically to ensure that, hey, the state has been updated and so has the core validated. You might want to like change the frequency of it because your RPC, like the RPC that you're using might hit rate limits. So that is one thing that you might come across, which is why I'm using a dedicated RPC, but you can polling rate or make it manual. The user polls for it by themselves. Okay, yeah. Vibe coding is basically like waiting for things to work out and then debug it all over. We're almost close. We should be able to play the game soon. I think 3000 is already posted, so it might try to post on. Oh, yeah, that's right. All right, so we're live. Let's connect our wallet, MetaMask. Let's connect our wallet. Great. So it's the same mechanism. So you can see there are 3 rounds as opposed to our previous setup where we just had 1 round. I have a 6, so which is pretty low, but it doesn't matter. So I want to raise. And okay, I see that it's not updating, but we should be able to fix that soon. Let's again, we can basically merge this to one transaction. Yeah, as you can see, the computer has won. And round 1 was won by the house. And we can, yeah, basically how many rounds you want, or you can just fold and stop playing right now if you don't want to continue. You'll be able to pick your card and shut down. So this raise also depends on how much you have initially deposited. You can deposit more to raise more. And settling the round basically reveals the values. Crazy. Yes. And we won. Same thing. So house won first, then I won. Again, pick my card. I can choose to stop now, or basically like go to the next round. Yeah, this is a pretty good chance. So I will be. So you can also reduce the number of transactions by just making sure like some of these steps are merged. And yeah, so I beat the machine by winning 2 rounds, and I'll be able to claim the ETH that belongs to me. Uh, I see that I've not won much, but yeah, you should be able to claim the ETH, and you won the game. So we have few other games that you can work with. Of course, right here it won't show up because we are yet to give like deploy and give an address, but you should be able to play them over here. So in the main application before you start working with it. Same here in blackjack, right? So one game that I played, I had got in a perfect 21, whereas the computer or the dealer was burst. So I get the yes, I'm not sure why it says house. But yeah, so I was able to claim these funds. This is probably a bug because I have gotten these funds already. I was able to claim it. So this is how we can build using the confidential deck. You can also change the card lib, basically library. So it need not be just these games. You can have a different like game mechanism over here. So yeah, that is most of it. I will be sharing the resources over Telegram once you guys join, or Discord, or any of the channels that we have. Thank you.
Cool, great. Thank you, Sudeep. So yeah, I hope you got a lot from that. That was the kickoff to the game jam, a little introduction to Inco and Sudeep building something with Inco. So yeah, we'll be back tomorrow with the Megapot kickoff. So yeah, if you go to the Inco website, inco.org, you go to the blog, there is a blog which has everything you need to know. It has the workshop schedule, it has hackathon rules, it has everything. So yeah, thanks again, and yeah, catch you guys soon.